a rare messenger from another star system, is currently passing through our cosmic neighborhood, offering scientists a fleeting but extraordinarily valuable opportunity to study material formed around a different star. Comet 3 I/Atlas, also known by its formal designation C/2025 N1 Atlas, is only the third confirmed interstellar object ever detected inside our solar system, following the surprising discoveries of 1 I/Oumuamua in 2017 and 2 I/Borisov in 2019. Unlike typical comets that originate in the Kuiper Belt or the distant Oort cloud, 3 I/Atlas was born far beyond the Sun's gravitational influence, likely within another planetary system entirely. Its arrival marks a continuation of a new era in astronomy, one in which visitors from other stars are no longer theoretical curiosities, but observable, measurable objects that can be studied in real time. What makes 3 I/Atlas particularly compelling is not just its interstellar origin, but the way it is behaving as it journeys through the inner regions of the solar system. Over the past several days, astronomers have reported subtle yet scientifically rich changes in the comet's appearance. Most notably, its coma, the cloud of gas and dust surrounding its nucleus, has developed a faint green glow. This greenish hue is familiar to comet scientists and is typically associated with diatomic carbon C2, a molecule that fluoresces when exposed to ultraviolet sunlight. The presence and intensity of this glow provide clues about the chemical composition of the comet's ices and how they respond to solar radiation. Because this object formed around another star, these chemical fingerprints may reflect conditions in a completely different protoplanetary disk, offering a rare comparative data point for understanding how planetary systems form across the galaxy. At the same time, 3 I/Atlas is drawing attention across the electromagnetic spectrum. X-ray observatories have detected emissions produced as the comet's escaping gases interact with the solar wind, a stream of charged particles constantly flowing outward from the sun. While X-ray emission from comets is not unprecedented, it remains relatively uncommon and is especially intriguing in the case of an interstellar object. These X-rays are generated through a process known as charge exchange, in which highly charged ions in the solar wind steal electrons from neutral atoms in the comet's coma. Observing this interaction allows scientists to probe both the composition of the comet's gases and the properties of the solar wind itself. The result is an unusually rich, multi-wavelength observing campaign that spans optical telescopes, infrared instruments, and space-based X-ray observatories, making 3 I/Atlas one of the most closely studied comets of 2025. As interest in the comet has surged, so too have sensational headlines and speculative social media posts, prompting NASA and other space agencies to emphasize a crucial point. 3 I/Atlas poses absolutely no threat to Earth. According to NASA's calculations, the comet's closest approach to our planet will occur on December 19, 2025, when it will still be about 1.8 astronomical units away. An astronomical unit is the average distance between the Earth and the Sun, roughly 150 million kilometers or 93 million miles. At 1.8 astronomical units, 3 I/Atlas will be approximately 270 million kilometers or 170 million miles from Earth, nearly twice the Earth-Sun distance. This is an immense separation by any standard, placing the comet well outside any range of concern and firmly in the realm of scientific curiosity rather than planetary hazard. Understanding the name 3 I/Atlas also helps demystify the object. The 3I designation signifies that this is the third interstellar object ever confirmed passing through our solar system. The previous two, Oumuamua and Borisov, transformed astronomers' expectations by proving that such visitors are detectable and not vanishingly rare. The Atlas portion of the name refers to the Asteroid Terrestrial Impact Last Alert System, a NASA-funded network of survey telescopes designed primarily to detect potentially hazardous near-Earth objects. It was one of these telescopes, located in Rio Hurtado, Chile, that first reported the object to the Minor Planet Center on July 1, 2025. That discovery set off a global response, with observatories around the world quickly turning their attention to the newcomer. One of the defining characteristics of 3I/Atlas is its hyperbolic trajectory. Unlike comets bound to the Sun, which follow elliptical orbits and return periodically, a hyperbolic path means the object is moving too fast to be captured by the Sun's gravity. It entered the solar system from interstellar space, is currently passing through on a steep, open curve, and will eventually depart, never to return. This one-time visit underscores the urgency of studying the comet while it is accessible, as there will be no second chance once it fades back into the darkness between the stars. Speed is another striking aspect of this interstellar traveler. When 3I/Atlas was discovered, it was already moving at approximately 137,000 miles per hour, or about 221,000 kilometers per hour. As it approached perihelion, the point in its orbit closest to the Sun, it accelerated further, reaching speeds near 153,000 miles per hour, or 246,000 kilometers per hour. After rounding the Sun, it will gradually slow relative to the Sun's frame of reference, but it will ultimately depart the solar system at roughly the same tremendous speed with which it arrived. These velocities are far higher than those of typical solar system comets, and are a direct consequence of its interstellar origin. Scientifically, the importance of 3I/Atlas lies in what it can reveal about environments beyond our own solar system. Each interstellar object carries with it a physical record of the conditions under which it formed: temperature, radiation levels, chemical abundances, and dynamical history. By comparing the composition of 3I/Atlas with that of native solar system comets, scientists can test whether the processes that shaped our planetary system are common or unusual in the galaxy. The detection of familiar molecules, such as carbon-based compounds, alongside any unexpected chemical signatures, could reshape models of planet formation and the distribution of organic material across star systems. There is also a broader philosophical and scientific context to these discoveries. For decades, astronomers suspected that interstellar objects must occasionally pass through the solar system, ejected from their home systems during the chaotic early stages of planet formation. Yet, until 2017, none had been definitively identified. Now, with 3 confirmed detections in less than a decade, it is becoming clear that such visitors may be relatively common, even if they are difficult to spot. Improvements in survey technology, data processing, and international collaboration mean that future discoveries are likely, potentially turning interstellar objects into a new and routine field of study. For the public, 3I/Atlas serves as a reminder of both the vastness of space and the interconnectedness of the galaxy. A small, icy body formed around another star has traveled for millions, perhaps billions of years before briefly intersecting with our own planetary system. Its passage is silent and distant, posing no danger, yet it sparks curiosity and wonder while quietly contributing to humanity's understanding of the universe. In that sense, the comet's subtle green glow and faint X-ray emissions are not just scientific data points. They are signals from a faraway place, temporarily illuminated by our sun, telling a story that extends far beyond the boundaries of our solar system. As 3I/Atlas continues on its journey, telescopes will track it for as long as possible, extracting every bit of information before it fades beyond detection. When it finally disappears back into interstellar space, it will leave behind a legacy of data that will be analyzed for years to come. More importantly, it will reinforce the idea that our solar system is not an isolated island, but part of a dynamic, ever-changing galactic environment where material is exchanged, stars are connected by wandering debris, and even the smallest visitors can deepen our understanding of the cosmos.